The handout of class notes that was given to you, we're going to work through the problems and some application problems after that to prepare you for the homework assignment for tonight and to get you ready for tomorrow's lesson. So what we'll do is we'll look at all of the odd problems on this sheet and give you some time to work through the even ones, and we'll do some application problems after this set. So in questions 1 and 2, you're being asked to classify the triangle as acute, obtuse, or right. And so the first thing you have to do is you have to decide which is going to be your longest side. Well, I know that the square root of 13 is going to be my longest side, so I'm going to compare the square root of 13 squared to the square root, or 2 times the square root of 2 squared plus 3 squared. And when I compare them, if I end up with them being equal, then they have to be a right triangle. If I end up with them being acute, less than, then it's an acute. If it's greater than, then it's obtuse. So from here, this is going to give me 13 because whenever I square root, the square root goes away. And we're still comparing it to 2 squared to 2 squared is going to give me 8 plus, and then 3 squared is 9. So this gives me 13 is less than 17. And if c squared is less than a squared plus b squared, then that makes it an acute triangle. In 3 and 4, you're finding the length of the missing side. So this is where you'll use the Pythagorean theorem. And so our c value will always be opposite our right angle, making it our hypotenuse. So in number 3, we're solving for the hypotenuse. So I know that the square root of 5 squared plus the square root of 6 squared is equal to x squared. So that means 5 plus 6 has to equal x squared. So I have 11 equals x squared, and x is equal to the square root of 11. Kilometers. For number 5, we found the area of each triangle. And so to find the area of each triangle, then we need to know the base and the height. And so in this case, I'm going to use the Pythagorean theorem to solve for the height of my triangle. So I have 8 squared plus 7 squared is equal to 8 squared. So 8 squared plus 49 is equal to 64. And I have 8 squared is equal to 15, which means h is equal to the square root of 15. And then to solve for my area, I have 1/2 my base, which is 7, times my height, which is the square root of 15. So my area is going to be 7 square root of 15 over 2. This says to round it to the nearest tenth, so I'll let you do that in the calculator and round it off. For number 7, in order to solve for our area, we're going to need to know this piece of our base, and to do that, we're going to use the Pythagorean theorem again. So I have x squared plus 8 squared equals 9 squared. So I have x squared plus 64 equals 81. So x squared is equal to 17, and x is equal to the square root of 17. So what that means is my area is going to be equal to half of my base, which is 22 plus the square root of 17, times my height, which is 8. So this is going to give me 22 plus the square root of 17 is about 26.1. And then we multiply that by 4 because that's half of 8. So this is going to give me 104.5 for my area. And in number 9, it's a similar setup because I have to solve for both pieces of my base in order to find my area. And to do that, I'm going to use the Pythagorean theorem twice. So in this case, I'll call this A and this B. I need to solve for A and B. So A squared plus 8 squared, it has to equal 18 squared. So A will be the square root of 260. And then for B, if you know your Pythagorean triples, then I know that this is B is equal to 6. But if you don't know your Pythagorean triples, then you'll have B squared plus 8 squared equals 10 squared. So you'll have B squared is equal to 100 minus 64, which is 36. And when I take the square root of both sides, I get 6. And then to find my area, I'm going to have half of my base, which is 6 plus the square root of 260 times my height, again, which is 8. So 6 plus the square root of 260 is going to be 22.1, and then I multiply that by 4 because that's half of 8. And this is going to give me an area of 88.5 when we round it off to the nearest tenth. In numbers 11 through 20, you are using your properties of special right triangles. So in this case, I have a 45, 45, 90. So I know that V has to equal 6. And then from there, if you don't remember that the hypotenuse is going to be the length of your side times the square root of 2, then you can always set it up using the Pythagorean theorem to show that 6 squared plus 6 squared has to equal u squared. Well, this will be 72 equals u squared, and u is equal to the square root of 72. Well, when we leave this in simplest radical form and we simplify the square root of 72, this is going to give me the square root of 2 times 36, and we take the square root of that 36, so u is equal to 6 times the square root of 2. Which, if you remember your rules for special right triangles, then you don't have to do all of the Pythagorean theorem work. If you take a look at number 13, it's another special right triangle. So in this case, we have the side opposite the 30 degrees, which makes it the short leg. And so I know that u is equal to 2 times that short leg, which makes it 6. And again, if you don't remember the rules for your special rights, then you can say 3 squared plus 6 squared, plus v squared has to equal 6 squared. So this will give me v squared is equal to 36 minus 9. So I have 27. So v squared is equal to the square root of 27. And the square root of 27 is going to factor into 3 times 9, and we take the square root of 9. So v is going to be equal to 3 square root of 3, which, if you remember your rules, then you would know that without having to do all that work. Numbers 15 through 20 get a little bit harder with a couple of multi-step problems. And so the first thing I'm going to do in number 15 is I need to figure out what this side length is so I can figure out what x is. Well, if this is a 45, 45, 90, then I know that this side has to be 5. And if this side is 5, then I know that this side has to be 5 square root of 2. And if this is 5 square root of 2, because it's the leg of another larger 45, 45, 90, then I know that this x has to equal 5 square root of 2 times the square root of 2. So this is going to give me 5 square root of 4, and the square root of 4 is 2, so x is equal to 10.